Hello, geometry students. Welcome back for Chapter 7. So Chapter 7 is all about similarity. And so in order to take care of similar figures, we need to know how to use ratios and proportions. So Section 7.1 is just a flashback to algebra, solving ratios and proportions, and maybe doing a little bit with them. So first of all, the important thing is ratio is just a fancy word for fraction. So if you're ever thrown off, a ratio is a fraction. Typically, it's a comparison of two quantities. We see it all the time. We typically write it as a fraction, so A over B, but you could use a colon and say A to B. When we do an extended ratio at the end of this section, we're going to have to use that colon because you can't have three parts of a fraction. And last but not least, I would be remiss if I did not tell you, you must simplify. You can leave it improper, but you must simplify. You cannot have any common factors. So let's do a couple quick talking. So sometimes we've got ratios and we can put them in words, right? Not just here's a fraction, good luck. So the total number of students are participating in sports at Central High School is 500. The total number of students in the school is 1850. So it says find the athlete to student ratio. So athlete to student. So how many athletes are there? 500, right? How many students are there? 1850. When you simplify that down, because we are definitely not going to leave that, if you need some help using your calculator or figuring out how to simplify, I can probably divide both of those by 50 or some large, at least 10. I believe that simplifies down to 10 over 37. So the ratio of athletes to students is 10 to 37. Letter B, I wanted to keep this in here because it's a sneaky problem. You've got to make sure you do your reading. You know how geometry can be. Athlete to non-athlete. Athlete to non-athlete. So, oh, and I forgot to say, I should have said this as well. For letter A, 10 to 37 could also be written like 10 to 37. It looks like a time, like morning or evening when I'm already sleeping, but you can write it that way as well. Athlete to non-athlete. Well, we know the number of athletes is 500. We've already used that number. Non-athletes is not given, but you can know it, right? If there's 1,850 students at the school and 500 are athletes, the rest of them must not be athletes. So I believe that's going to be 500 to 1,350. Of course, you're going to simplify that, and that comes down to, I think that one's a 10 to 27. And you could write it as 10 over 27 or 10 to 27. Either way would be perfectly right. Most of us have a preference to leave it in looking like a fraction, but you are more than welcome to write it as a proportion with the, or as a ratio with the colon. All right, so we know that a ratio is a fraction. A proportion is an equation stating that two ratios are equal. So a ratio is just a fraction. The proportion throws the equal sign in there. So in order to solve a proportion, we use cross products, or perhaps you have heard it called cross multiplying. I can't remember what I've got here yet. We usually call it cross multiplying, right? That's how I learned it anyway. I don't know if you know cross products. So this is two things that we could do with this. We can determine if ratios are equal. Look at example A, 2/3 question mark 6/9. Or we can use it to solve for a variable. Look at example B, 6 over 8 equals something over 12. So there's really two purposes for this. One or two. And cross products or cross multiplying means the product of one diagonal has to be equal to the product of the other diagonal. Some of you learned some interesting ways, looks like a bow tie, all kinds of things, but you're doing the same thing. So example A, you probably are intelligent enough to realize that yes, those two things are equal. 2/3 is equal to 6/9. You could turn them both into decimals and see if they come out to the same decimal. You could cross multiply. So what I'm saying is if I wanted to use cross products to check if they're equal, if I multiply this, 2 times 9 is 18, and 6 times 3 is 18. Since those two products are equal, these two fractions are equal. Put a big equal sign in between there. Example B, if I'm going to solve this one, notice I've got a variable, so I'm wondering what that value is. We can cross multiply to solve that. I always like to multiply the diagonal first that has the variable because I like the variable on the left, so I'm going to go this way first. 8x. Don't forget to put your equal sign in the middle. 6 times 12 is 72. So when you divide both sides by 8, x must be equal to 9. You might have been able to figure that out a different way, but we're going to have some problems that look a little messier. I want to take a quick look at problem 2b just to make sure if you did that a different way, if you just did 6 times 12 and divide by 8, because I know some of you know some shortcuts for that, that's awesome. But 2b, notice I've got an x minus 2 as that first numerator. Think of it as parentheses around it. You can't just shortcut this one. You got to slow down a little bit. So when I cross multiply this way, I've got a 5 with an x minus 2. Probably you're not going to write that out. You're probably going to just write 5x minus 10 and distribute. Put the equal sign. That's got to be equal to 8. And then I can solve from there. So add 10. So 5x equals 18. Divide by 5. So x is something like 18/5, or perhaps you want to put it as 3 3/5, or 3.6. Typically, if you start with a fraction in a problem, you end with a fraction in a problem. You don't mix decimals and fractions. So be careful for those distributive property problems. And I know you've done these, but just make sure you've got a refresher. So let's talk about writing our own ratios and then making a prediction. So a designated hitter made 8 hits in 10 games. Find the ratio of hits to games. So just a fraction, right? Hits to games. So hits has to be on the top to games. Sometimes it helps when you label it too. So this one's pretty easy, right? How many hits? 8. How many games? 10. Of course, we're going to simplify that down. So for every 4 hits, he played in 5 games. Letter B says, predict the number of games necessary for the designated hitter to make 56 hits. Use the ratio from 3a. Now, you might be able to just work your way through this and common sense your way through it, and that's great. But if you can't, we're going to take this ratio of hits to games. So 4 hits for every 5 games. Hits have to be on the top, games have to be on the bottom. And it says predict the number of games necessary, right? So that's our x, because how many games do we need to make 56 hits? And then I can cross multiply to solve that. I'm going to multiply first and do my 4 times x. And 5 times 56, somebody grab a calculator, make sure I'm right when I say it's 280. Divide by 4, so x means that designated hitter has to hit in 70 games. So we just used our ratio and set up a proportion to make a prediction. All right. So far, so good, right? This is all review. I hope. My fingers are crossed. I know you can't see them. So an extended ratio, there's 2 things about this. It compares 3 or more numbers. We won't go past 3. So we're comparing 3 things instead of just a regular ratio that compares 2 things. So this one, we always use the colons. We'll say A to B to C. So this is really helpful when we talk about something like a triangle, right? Because how many sides does a triangle have? How many angles does a triangle have? 3. That's an extended ratio. So in a triangle, the ratio of the measures of the 3 sides is 5 to 12 to 13. The perimeter is 90 centimeters. Find the measure of each side of the triangle. This looks a bit intimidating at the beginning, but if you know me at all, you're going to know the first thing I'm going to want to do is draw a picture and I've got myself a triangle. Now, obviously, I don't go for fancy pictures. The ratios of the three sides is 5 to 12 to 13. So I'm just going to put those on the sides, 5 to 12 to 13. It's pretty obvious I drew a terrible triangle. Here's the thing, the perimeter equals 90 centimeters. Does everybody know that perimeter is the sum of the sides? So when I add up those three sides, it says that they add up to 90, but 5 plus 12 plus 13, it's definitely not 90. So there's a nice little thing. Remember how I said, and I should have said it again over here. I know I don't have a bullet for you, but always simplify. So 5 to 12 to 13 is simplified. So here's the easy peasy way to do this. Follow carefully, you're going to get it. I know that I divided everything, all three of those numbers, by something. So to unsimplify, I'm going to times all three of these by some number to get it up to a large enough number. So when I add them up, they end up to be 90. You might be able to common sense and trial and error your way through this, but there's a, I think, easier way to do it. Now if I take all three of these values, 5x plus 12x plus 13x, they are equal to a perimeter of 90. Easy solve. We can figure out how we simplified. So x is our simplified, that's what we divided everything by. So let's see, 5 plus 12 plus 13, that comes out to like 30x equals 90. So that's an easy x equals 3, right? But 3 is not the length of my side. It says find the measure of each side of the triangle. So if this side is 5x, x is 3, so this side has to be 15. 12x has to be 36 because I multiply those. 13x has to be 39. I'm hoping you notice that there's a built-in double check here. If I add up 39 and 36 and 15, what should they all add up to? 90, right? That's how I know that I got that problem right. So when I set up an extended ratio, 15 to 36 to 39, everything could be divided by 3 to simplify it. All right, so that might be a great example to refer back to. Make sure you look at that equation that we set up. We set x's on each one of our parts of our extended ratio. This one's a good one. The ratios of the angles of a triangle are 3 to 4 to 5. Find the measure of each angle. So again, triangle, not a very good one. Are we dealing with sides or angles on this one? Right, so angles. I don't know anything about the sides, but I know 3 to 4 to 5. Now, obviously, those angles are not 3, 4, and 5 degrees. Doesn't make any sense, right? But you know how in that last problem I wrote down perimeter equals 90 because it told us what the sides had to add up to? In a triangle, what do the angles have to add up to? 180 degrees, right? Angles equal 180 degrees. Triangle sum theorem. That one just keeps popping back around, doesn't it? So I'm going to do the same thing here. This is literally not 3 degrees. It's simplified. So I divided everything by something in order to simplify down to 3, 4, and 5. So I'm going to put x's on these again. So I know that my three angles, which happen to be 3x, 4x, and 5x, have to be equal to 180 degrees. Well, that seems even easier than the last one. So what is that, like 12x equals 180? Divide both sides by 12, and x is something like 15. But we're not done, right? It says, what are the measures of each angle? So if this angle is 3x, plug that 15 in there, what's that going to be, like 45 degrees? 5x, 5 times 15, I believe, is 75 degrees. And 4 times 15 is 60 degrees. And just to check your math, your built-in double check, what should 45, 75, and 60 all add up to? If we did the problem right, it's going to add up to 180 degrees because that's what the angles have to add up to in a triangle. All right, let's do one last problem. Number 7 about perimeter. The perimeter of a rectangle is 220 inches. The ratio of its length to its width is 7 to 3. 7 to 3 is length to width. That's a nice thing to keep in mind over here. So guess what I'm going to do first? Draw a rectangle. Doesn't have to be fancy. I will not grade you on your rectangle drawing ability. And then it says, it says at the beginning, the perimeter is 220 inches. So length to width is 7 to 3, right? So 7 to 3. But that's obviously not 7 inches and 3 inches because it certainly wouldn't add up to 220 inches. So this feels a lot like the extended ratio triangle problem, but we don't have an extended. We just have two values in our ratio, 7 to 3. However, how many sides do you have in a rectangle? If you know that this bottom side is 7, don't forget that you've got a congruent side in a rectangle. The top side has to be also 7. If this right-hand side over here is 3, we've got the opposite side is congruent. Don't forget there's 4 sides in a rectangle. So now I'm going to do exactly the same thing. It's literally not. If I added those guys up, 7, 7, 3, 3, it would not add up to 220, right? So I'm going to put my x's on here because I know that a ratio is simplified. That's the rule. So now I can easily do perimeter is the sum of the sides. 7x plus 3x plus 7x plus 3x is equal to 220. You probably did that a lot shorter than I did, maybe said 14x plus 6x or something like that. But I believe that's going to come out to 20x equals 220. So x must be equal to, what is that, like an 11? I think that's an 11. So are we done with this problem? X is 11, that's great. Find the area of the rectangle. Sneaky, right? So I guess we probably need to know the sides. So if this side is 7x and x is 11, this side has to be equal to 77, as does this side. If this side is 3x and x is 11, then we know that this side has to be 33, and this side has to be 33. So how do you find the area of a rectangle? I know you've done this before too. Area of a rectangle is equal to base times height or length times width. I don't love length times width. I wish they had used length base times height, but that's all right. So does everybody agree in order to do our area, length times width or base times height, looking at the picture, area is going to be equal to 33 times 77. I cannot do that problem in my head. I have to grab my calculator. It looks like the area is going to be 2,541. If we're being technical, that's square inches. So that was a sneaky problem. We had to start it off the same way and still figure out what x is, still figure out what the sides are, and then look and see what was the question that it wanted us to answer. So a review on solving proportions, and then I'm not sure if you've done ratio problems quite that way, and probably you've never seen extended ratios. So we've got some work to do, and I will see you in section 7-2.